Today we're going to talk about solving systems of equations by elimination, just like we did yesterday, but this time we're going to add multiplication in there. So yesterday you either just had to add or subtract. You might have a system like x minus y equals 5 and negative x plus 2y equals 7, and all you had to do was subtract. Today we're going to have systems where it's not going to be just quite that simple. So you're going to have to multiply one or both of your equations first, and with the goal in mind, again, of eliminating a variable. So for example, I have this system here, and if I look at it, I should notice that I can't just add or subtract, because if I were to add these, I would get negative 2x plus 5y equals 17. And you can't solve that. You need to have the two equations so that you can solve. Okay, and we need to eliminate a variable because that's how we know how to do it. So what can we do? We can multiply all the way through one equation or both equations if we want, and then add or subtract. So if you look, notice that I've got a positive x and a negative x. Okay, positive x, negative 3x. So if I'm going to add, the x's are going to eliminate, but I've got to make sure that I have the same thing. So what I can do is I can take this original equation and multiply it by 3, and then I get 3x plus 3y equals 2, and then I'm just going to leave my second equation the same. But I like them lined up because then I can easily see what I'm adding or subtracting. Okay. I know some of you guys like to write all over the place and you don't like to be nice and neat. I'm begging you to be nice and neat when you do this. Write down the original problem so you can look at it and you can see. Write down what you're going to multiply and then multiply through. Follow what I do because it's nice and neat, and it's going to be a lot easier for you to find your mistakes and a lot easier to follow the steps. And hopefully you won't have to find mistakes. So now if I'm going to add these, okay, I'm going to, if I add 3x and negative 3x, it cancels out. Bam, right? 3y plus 4y is 7y. Okay. And Miss Craig made a mistake right off the bat because I needed to multiply, and that's a common mistake, that by 2 as well, so it's going to be 6. Okay. And 6 and 5 is 21. I'm going to divide by 7, and y equals 3. Okay. Now that I have a value for y, I'm going to substitute that value into either of the original equations. And I'm going to put it into the first one, which was x plus y equals 2. So x plus 3 equals 2. And if I subtract 3 from both sides, x is going to equal negative 1. So my ordered pair is going to be negative 1, 3. So that's my answer. Okay, now, do I have to do it that way? Absolutely not. I'm going to actually do it another way here, and I'm just going to show you. Again, we're looking for things that we can get rid of. So here's my originals. X plus y equals 2, and 3x, negative 3x, plus 4y equals 15. Okay. Let's say that I want to get rid of my y's instead. Okay, so if I look at my y's, this one here is 4, and this one here is also 4, is 1. So I would have to multiply, if I wanted to get rid of the y's, my top equation by negative 4. So if I multiply by negative 4 everything, you'll see that it's going to get me rid of one of my variables. So if I distribute that negative 4, I'm going to get negative 4x minus 4y equals negative 8. And then I'm just going to take my original second equation, and I'm just going to keep everything lined up. All right. So if I add now, negative 4 and negative 3 is negative 7x. Negative 4y plus 4 is 0y or 0, so they cancel out. And then I get negative 8 plus 15 is 7. When I divide by negative 7, I'm going to get x equal to negative 1. And then I'm going to plug it in. I'm going to use the easier equation, the x plus y equals 2. So negative 1 plus y equals 2. If I add 1, y equals 3. So notice I got the same answer, negative 1, 3. So there's lots of different scenarios that you can use to solve this system. Let's look at the next example. I actually wrote these down twice because I wasn't sure I'd have room. All right. So there's really no clear-cut way here. I don't have an x and a y, so I want to look. I can do one of two things. Notice that they're both positive and negative, the x's. I've got one negative and one positive, or I've got one negative y and one positive y. So the easiest thing, it looks to me, would be to get rid of the y's because 6 is a multiple of 3. Because 3 times 2 equals 6. So I'm going to multiply both sides, or all parts of this, by 2. So when I do that, I'm going to get 6x minus 6y equals negative 12. And then I'm just going to bring my other original equation over so I have everything lined up nice and neat. Okay. So when I add now, 6 and negative 5 is positive 1, so I get 1x. Negative 6 plus 6 is 0, so 0y, so they cancel out. Negative 12 times 12 is 0. Valid answer. X equals 0. And then I'm going to plug it into, I don't know, let's do the second equation, just to be different. So negative 5 times 0 plus 6y equals 12. 6y equals 12. If I divide by 6, y equals 2. Okay. Let's look at another way that we can solve this. My equations, original. Since I have both a positive and a negative x, let's get rid of the x's. And as I'm looking at the x's, one's not a multiple of the other, but I should be able to see that if I found a greatest common multiple or least common multiple, if I write out my 3's, I get 3, 6, 9, 12, 15. If I write out my 5's, for those of you that aren't really good with those, 5, 10, 15. So let's make them both 15s. So to do that, I've got to multiply the first equation by 5 and the second equation by 3. And when I do that, okay, I'm going to get 15x minus 15y equals negative 30. Second equation, I'm going to get negative 15x plus 18y equals 36. Should be 30, that's a 0. So now when I add 15 and negative 15, those cancel out. Negative 15 plus 18 is positive 3, so 3y. Negative 30 plus 36 is 6. So now I'm going to divide by 2. So y equals 3. And then I can pick whatever equation I want. I'm silly. Hope you caught that. I'm going to divide by 3. I was thinking ahead, and y equals 2. Now I'm going to put that 2 back in. I'm going to do it to the first equation this time just to be different. So 3x minus 3 times 2 equals negative 6. So 3x minus 6 equals negative 6. If I add 6, I'm going to get 3x equals 0. Okay, so then I divide by 3, so x would equal 0. So again, I get the ordered pair 0, 2. And I got it in both cases, 0, 2. So that's my solution. Now let's look at a messy one, because you guys don't like fractions. But you have to know how to deal with the fractions. So I'm just going to, first thing I'm going to do is I'm going to change these to mixed numbers, or to improper fractions. So 2 and 3/4 is going to be 11/4. 9 1/4 is going to be 37/4. Okay. I want to get rid of the fractions, and that's my first step. So I'm just going to multiply everything by 4 to get rid of my fractions. Okay. So if I do that, I'm going to get x. 4 times 4 is 16. Y. 4 times 11/4, the 4's cancel, so that equals 11. Okay. Distributing on the second. 4 times 3 is 12, so I get 12x. 4 times a half, so a half of 4 is 2, so plus 2y. And 4 times 37/4 is 37. Okay. So this might make it a little easier to see what we can multiply or divide by. I want to get rid of the x's, that's just me. You can get rid of the y's if you want. And I can do that by multiplying this by negative 12. So if I multiply everything in my second equation by negative 12, I'm going to get negative 12x minus 192y equals negative 132. Then I'm just going to keep the second equation the same because my x's are going to cancel out. So I get 12x plus 2y equals positive 37. So now I'm going to add my equations. So negative 12 and 12 is 0. They cancel out. Negative 192 plus 2 is 190y. Negative 132 plus 37 is negative 95. If I divide by 190, I'm going to get y equal to a half, or 0.5. Then I'm going to put that value in, and I'm going to use the equations that I multiplied through, so I'm going to use this equation right here. So I'm going to do it over here. X plus 16 times a half equals 11. 5/10, remember, is equivalent to a half. So half of 16 is 8. If I subtract 8, I'm going to get x equals 3. So my solution is 3 and 5/10. Okay. So I looked at a couple different methods, or a couple different things solving by linear combinations. So we can multiply one equation all the way through, or both equations all the way through to get my variables to have opposite coefficients so they cancel out. Have a great night. If you have any questions, make sure you ask me in class tomorrow.